All right, everyone. So let's get back to the class. The size of the class is shrinking every day, which is a very normal thing as the class progresses. I don't know why we couldn't have a lecture last week, but that means you were set back by one class. So I need to cover that up because the closer we get to the exam date, it's going to become harder for us to cover all the material. So today we're going to cover two things. We're going to cover the last part of the machine learning, and we're also going to cover the problems or limitations with AI. And I'm going to try to see if we can do this today. After that, we're going to jump to generative AI. Just going to think about LLMs. Going to talk about LLMs. Going to talk about how we work with LLMs. Not how you develop them. Again, out of scope. This is to give you an idea what generative AI is. How you studied machine learning, you should know LLM, generative AI, prompt engineering, how to work with prompt engineering. I could bring some people from Router to give you an idea how they work with their Router GPT and these kind of things. So we'll use like three or three classes just on generative AI, and then we are going to be done. Okay. So we have covered the supervised machine learning part. Now we are going to cover the unsupervised machine learning. And if you remember from last time, when we spoke about unsupervised machine learning, it was mostly like the data you have. You don't really know what kind of data you have. So you just give the data as is to your algorithm. And the algorithm then tries to find different clusters and different patterns inside your data. Unsupervised machine learning is a much better approach to use when you don't want to put so much focus into cleaning your data sets, or you don't want to put so much focus into labeling your data sets. So it's a cheaper AI to work with in essence. Two types of unsupervised machine learning. You have clustering and association. We'll start with the association part. So association is something which relates things or entities with each other. We are related because we are in the class. We go to OsloMets and we meet at 8:30 every Wednesday. These are our associations, right? Something associates us. We live in Norway, we live in Oslo, blah, blah, blah. Certain associations. Then if you take the same association rules and you go to a supermarket and you're looking at different things to buy, then yeah, like if you're going to buy milk, you might end up buying bread, you might end up buying cheese. Think for an instant, when you go to a supermarket every week or every second day or every third day, what kind of things do you normally buy? In our habit, we normally buy the same things over and over again. When a weekend comes, we buy the same things. Either you are buying some drinks or you're buying some snacks, something, or candy, for example. You will realize you keep on buying the same thing, and that becomes an association for you. And that association is very important because every person has a specific pattern or habit to do specific things. And those specific things are the associations which big supermarket chains are looking for. They want to see what people buy before they're going to buy this. And a very clear example is on big retail sites like Amazon.com. As soon as you buy something, they'll keep on showing you ads of next thing you would buy, and so on and so on. So that happens with association. Did I tell you the example of beer and okay, so I guess I have told you, but I'll just repeat it anyway. One of the associations they found very interesting in the US markets was that men who were buying beer in the evenings were also buying clothes or food for their kids as well. Like if you're going to buy Pampers or Blyer for your kids, you probably end up, and you're a man, you probably end up buying beer more. When they found this association, they kind of put those two things together. So if you're going in the store and you're going to buy Pampers, Blaya, you're going to buy beer as well. That increased the sale of both of the products. So this is a very important insight. And for some reason, it only happened on Thursdays. It didn't happen on Friday. It didn't happen on Monday, Tuesday, Wednesday. It happened a lot on Thursday. And they made sure that on Thursday, these two products should be together. I have a kid. I don't know why I would go on Thursday to buy a pamper and buy a beer at the same time. These are just transactions. So an example of a few transactions coming from different shops. And it just gives you an information on what was bought together with something else. So you had milk with some vegetables, you had vegetables and then diapers and then alcohol and chard and blah, blah, blah. So most of the stuff can be random, right? You might not have any association at all. Sometimes you're just feeling out of the blue and you want to buy so much candy and just buy candy, but candy is not something you're going to buy every day. So that's one of things. So those are like random values in the data set. But most of the things correlate with people around you. So take a look at transaction number 3 and 4. These are for two different kind of people. And these people were buying more or less the same thing, but one person bought wine and the other person bought orange juice, for example. These are the correlations which are important. So if we take the example of a grocery store are not interested in, if you have 1,000 people coming in, they're not interested in looking at 10 people or 100 people. They're interested in looking at the movement of the crowd, 70% of the people, 80% of the people. And when they identify that trend, that's the trend they're going to focus on. And if you are a person who comes in and in a month you buy lots of candy or lots of ice cream, they don't really care about that because they want to focus on the sales which is happening every hour, every day, and on a volume basis. So that's why the last two transactions are most important for you. Or number 1, 3, and 4. So that was association. Association is a field on its own. So when you talk about relationships between different things, and that's a part of unsupervised machine learning. We will cover association a bit more, cover different algorithms going into it. The other one is clustering. So clustering is okay. Clustering is yeah. If you want to find like how your data is, what's happening inside your data, and you tell the algorithm like, this is my data. I have no idea what's going on inside my data. Can you just find certain attributes or certain characteristics in the data? And when the algorithm looks at the data, then it tries to find patterns in how it kind of groups them together. For example, if you're looking at the data and you think like, I want to find out how many colors are in my data. I have no idea. There can be like 10 or 20 colors, and you apply the clustering technique. What the algorithm will do is try to group them together based on their color, without you knowing that there are 3 or 4 colors available in the data. So clustering is very important when you have no idea how things which go inside your data, and you don't have the time to go through your data and actually sort that data. I think I showed you an example a few weeks ago regarding how Ruther was using clustering to identify what people were talking about. I think I've showed that. Right. So the first algorithm in clustering is a k-means clustering algorithm. Yeah, so it's basically the data points first take a look at this. So what it tries to find is, it looks at a specific kind of data. First, it tries to identify the values or the properties of those data sets around it. So it can start from any random place. It can start, yeah, any place. It always starts very random. And then it goes in a circular path and it tries to identify things, well, not really a circular path, but it tries to identify all data points around it and tries to use the same information like, okay, if it's a yellow kind of data set, try to find all data points which are of color yellow. And it goes round and round and round until it finds the center of that data set. And then it stops. So that's like the k-means algorithm. So it tries to find the center of all that data. This is another way of identifying. So no color information, but you have 3 random data sets, and it's trying to find like the center of that, of all of those data sets. So why is it called like a k-means algorithm? K is the number of centers you want the algorithm to find. So I mean, over here you can see clearly you have 12 steps happening. So let's say you have k equals to 12. So it will try to find like 12 centers for the data set until it kind of stops. Another example to look at k-means algorithm is this. Like every time it finds the center of the data set, it will form another image. So, I mean, the center will not remain the same all the time. As soon as the center changes, the boundary of the data set also changes. And it will keep on doing this until it finds a unified boundary and reaches like a central point. Then it will know like this is the center I have. This is heavily dense data points. And now I have defined that all of those data points are talking about the same thing or have the same kind of characteristics. But that's how they cluster them together. So this algorithm will stop when, like now you have a huge amount of changes occurring. Let's start from 0 and yeah, here. You have a huge amount of changes occurring, like the shape changing and trying to find different center points, but it will automatically stop when it finds like the shape isn't changing that much, the center point isn't changing its location that much, and so on. Yeah. Yeah, k-means a very easy one to run. It's very easy to get started with a k-means algorithm. Just push your data into k-means and it will give you some kind of output which you can use. Users could come in document classification. Okay, fraud detection. The third point is very important because we were recently working in a fraud detection algorithm in Router, and what we did was we used a lot of clustering techniques. So k-means was one of the algorithms we use, and what you do in a fraud detection algorithm is that you so we have a huge amount of transactions, and then most of the transactions are fine. What you're trying to find out is a transaction which is an anomaly, which is going in the opposite direction than everyone else. So if you have a person who is trying to commit fraud, that transaction will look like an anomaly. Like if you look at a stock market price, for example, like it's very stable, right? Goes up and down, go up and down. But sometimes you see like a huge spike coming in or a huge downfall coming in, and it's hard to explain why that happened. Those are also anomalies in that kind of data set. And the fraud detection algorithm, those kind of anomalies also come in. What these k-means cluster algorithm do is they try to identify those anomalies, and you just push all the data you have, and it kind of sees like, okay, we think all these data points belong together, but these data points don't belong together at all. So k-means is not actually detecting fraud, it's just identifying all groups of transactions together. What we do next is we take the output from that k-means algorithm and we say like, okay, this cluster is all right, this cluster is all right. Everything which does not belong to a cluster is by definition a fraud situation. So we need to investigate that. And then we start investigating into those fraud situations. Right. Another algorithm is mean shift clustering algorithm. Very similar to k-means. It also tries to find the heavily dense location inside the data. And if it's trying to find like the most heavily dense point in a data set, the best use for that algorithm would be in image detection. And the reason is that if you're making an image detection algorithm, you want to see like every person has a unique face, right? And the reason why every person has a unique face is I mean, for us, we know that every person is different, but for an algorithm, the only reason they see why a person is different is because you have a specific number of distance between both of the eyes. You also have a specific distance from your nose to your eyes and the mouth as well. So that's how the algorithm sees that every person is different because almost everyone has a different kind of variables on their face. So but when you have eye scans happening, when you take a look at how your ears are positioned and how these things are positioned, that's where this kind of algorithm helps out because then it focuses on the heavily dense areas of your facial structures, and it kind of focuses only on those ones. The its execution is also very similar to the previous one. It has multiple iterations, and what it does is it starts randomly until it tries to find the most heavily dense point of your data set. Another example of how it could be run. Any questions on this one? I feel clustering is very straightforward. It's much easier than supervised machine learning. The third algorithm is a DB scan algorithm. So the way a DB scan it works is, yeah. I mean, instead of reading this one, let's go to the example. It always starts from the thinly dense population of data sets and it goes down to the heavily dense. Now, this algorithm Gaussian mixture model is an important one. And the reason it's important is because how it tries to figure out the density inside your data set. Gaussian works very much like k-means. They're very similar to the way they work, like k-means, dbScan, and Gaussian, but it's how you identify the boundary for your data set. The way k-means works is it tries to find, it has like a circular format. It always makes a boundary around your data set. However, when you are working with okay, yeah. So k-means will always try to identify the dense areas, but group them together in a circular format. So even if the data sets are far spread around, you would have like examples like this. And if they are very close, it will still make like a circle. So the boundary for that data set is over here, and the boundary is over here. So that also means that why is that a problem? The problem is that if you see these two data sets and they have like this kind of overlap, so this attribute could also belong to this data set, and that attribute could also belong to that data set, and that's a problem with that could be a problem with k-means because and everything inside the boundary which is not having an overlap with the other is fine. But if you have something close to the boundary and it's in a circular format, then everything close to the edge might belong to some other cluster. So that's something where you could have a problem with k-means. But instead of using k-means, if you use a Gaussian mixture model, what that model does is it tries to make the boundary based on the data set itself, very close to the data set. And then instead of having like a circular format or an oval format, it will make like a rectangle format or multiple boundary around your data, like however the data set is located, is arranged. So that would mean like, on the face of it, it would mean like Gaussian is much better than k-means, right? True, but k-means is very easy to work with, very easy to get started. So always start with k-means. And the one thing which programmers mostly do while working with these kind of clustering algorithms is to display the data display the data you have before and data you get afterwards. And only then you can see how your data is organized and how kind of value you get. So these examples which I give you, these are not hypothetical values. These are taken from actual machine learning examples. And that's because you are able to display how your data is behaving before putting it to the algorithm and after the algorithm. And if you see like, okay, now I see the algorithm behaving in this specific way, which is a problem, then you can change it to another algorithm which can give you a finer control over the boundary. Then a few other clustering algorithm, which we are not going to study at all. But if you are interested, you can study at your own time. Are Berg, affinity, optics, and agglomerative. Yeah. There are many of those, and they keep on coming. So I mean, it's mostly like your choice which one you want to work with. So we are now done with the clustering type of unsupervised machine learning. Do you have any questions on clustering? Clustering is extremely useful and it's extremely fun to work with clustering. Most people who start working with machine learning algorithms, they start with the clustering part just because you don't know what's going on with your data and you just want to find some trends that are happening in your data and you just give everything you have to the data set and the data set will kind of make some kind of structure or identify some kind of structure in your data set. So what certain people also do is they start with the non-supervised approach of clustering. They first do the clustering part, they get some kind of help from the algorithm, and then they push it to the supervised part. So the first part is done by the algorithm, and then you go to the supervised, and then you involve people who are looking at the data, fixing the data for you, and then you do some kind of supervised machine learning on it. So that's also a thing you could do. It entirely depends on your approach, how you want to see this. I got a question if I could explain Gaussian mixture model again. So I'm just going to cover it very briefly. The benefit of a Gaussian mixture model is that it tries to identify the most heavily dense areas in your data set. But so it's very similar to k-means or any other kind of clustering algorithm. However, a k-means algorithm, for example, will always have like a circular boundary around the data set, whereas a Gaussian mixture would kind of adapt the boundary as the data set is. So it can have a circular, it can have rectangle, it can have like a random, however the data set is. I hope that answered the question. Okay. So we covered the association algorithms a bit in the start, but let's look at associations, 2 more slides on association. So when you start designing an association algorithm, you have to think about association between objects. An association between objects is actually much more complex than we would normally experience in our day-to-day life. Because if you start with how things are grouped together, we're not looking at association like, okay, if it's orange, it's a fruit, and or if it's an orange, it might have an orange color and blah blah blah. This is something we know association which exists, but now we're talking about different kind of association. We're talking about association of behavioral patterns, how people would behave on how you're behaving on your computer, how you're behaving on your phone. We need to look at association in that way, and then what we need to see is how groups of people have been behaving in buying certain kind of products. And the same thing goes on social media, how groups of people have been behaving in looking at different social media feeds. Sometimes these stories come up on Facebook or TikTok or something, and they have huge likes and they have huge, they are very top on the scale. And the reason is a lot of people have been looking at those stories and they find this association. Okay, if the person looked at this story and they like this story, then they looked at that story and they looked at that story. So group them together. So most people can see, we think most people are looking at those kind of videos and so on. But then there's another kind of association that people who are looking at the least kind of like videos also find those videos interesting. So group them in this way and that way and that way because we think this will come next to the one and so on. Yeah. When I started using TikTok, it was like my feed was constantly changing all the time. And the reason it was changing all the time was sometimes my phone was being loaned by my son. And then he was accidentally doing this, and then you had random things coming in. Now, here's the thing. There are 2 kinds of association in a TikTok algorithm. You have a big common association, which is for the most popular videos, which is for everyone. And then you can go to the popular section and see all of those coming up. And that kind of association is based on how many likes the video gets. And that's a generic one for everyone. Everyone can see that. And then there's another kind of association, which is based on you, which is based on every video you see or every person you follow. There's an association being made. And when that association is made, you will kind of get a prediction like, okay, next video should be that one, or next video should be this one. So it's all about the history. Everything we do accumulates to a specific. So everything we do accumulates, or everything we do is kind of a history being formed. And when that history is used to predict what do we want to see next, that's what happened when you open up TikTok or you open up Facebook and you immediately see certain videos coming to your feed. And the reason they come to your feed is not because someone uploaded those videos. It's because the algorithm, the association algorithm, thinks that this is what you have been, this is something you saw earlier. This is something we think you would like to see. And most of the times they are correct. And that's why I think that's the beauty of AI, that it is able to predict in a very good way what we want to see. If you're watching a movie, for example, if you start watching a few movies and the algorithm, Disney, HBO, Netflix, all of them, they follow the same kind of rule. Every video you would see, it will try to predict what kind of next video you would like. But they also have this supervised machine learning part. Like it shows you a video, but then they ask you like, did you like this video or not? Should we recommend this to you or not? That is the data labeling part. So you are the data labelers for HBO, Netflix, and all of them, and you're giving feedback, I liked it or I did not like it. They use that information and they train the algorithm again by saying like this association which we figured out was wrong, fix it with that one. So that's the clustering part and that's the association part. And fraud. So let's talk about fraud. The same thing will happen in fraud as well. We have a lot of anti-money laundering checks in place, which makes sure, okay, you're a customer, you did these checks you completed, and then you are making certain transactions, and transactions go to Norway, fine. Transactions go abroad, okay, there's a different kind of risk associated, so an association will be made, more association will be made. When those associations become bigger, and they're like, okay, most of the transactions are going abroad, this person should be investigated more and spoken to more about. And then you get an email and all, but you have to reply to a few questions, and then those questions fix the algorithm, and then you're fine. So association algorithms are used more than we know. They're everywhere around us. And the reason why association algorithms became more famous was because of social media. And when Facebook, we had social media even before Facebook, but we never had that much focus on AI until Facebook came. Because when Facebook came in, there was a huge focus on investment into Facebook. They got the money to invest in their AI algorithms. And then anyone who could actually show you the right content was the king in the social media space. And once social media was well established, then everything started focusing on association algorithms. I've heard like Kiwi is doing the same. Rema 1000 is looking into associations to see how people behave and walk around. Do you know why they want you to use your apps to pay inside the store? Rema is doing that. Coop already wants to do that because they want to see what kind of products you are buying. And there are two kinds of information, two ways you can get that information, either from the point of sale systems when you go and pay for the bill. But those systems are very old. It's very hard to get data from those systems into the new big data system they're making. So they came up with a new strategy like, okay, give them apps and ask them to give them coupons from their apps, and they can use those coupons while they're buying in the store. Rema tells you to, okay, scan everything, you go there, and it's a good thing. I'm not saying it's a bad thing, but when this is the strategy they have. So when you are scanning everything, you're paying, you're buying in the store, you're also contributing to those association algorithms. So you're giving real time that I'm buying this, and that, and then they have a profile of you, and they know like, okay, this person has been buying this from this area, because they know where that specific object is located. And then they will get this information about where people are going, in which store, how they're buying, how they're moving around. And then they try to optimize it and they try to give you better products. This is not a wrong thing. It's a good thing that they're trying to increase your shopping experience. But it could be a bad thing if someone gives you an app and tells you, all right, like use my app and I will scan the products. And then they start collecting your data for illegal activities, which could be as simple as they might get information on if you're a person on a high position, they might get information on you, what kind of food this person eats, and if you have certain kind of allergies which you don't want other people to know, this could be used against you. Then there's location tracking information. People might use the location data to figure out where you are moving and so forth. I think I mentioned this Islamic Finder app problem, and there was this app being used by a lot of people around the world, religious people, and then it turned out they were selling location data to US military and so on. But that's one of the examples where it was actually found out. There are tons of dark web sites which collect your data and they sell your data, not even anonymously. They sell your data to a lot of other websites. I know my password has been breached so many times. Like when you go to Google Chrome password or Firefox, and like it tells you like, okay, we think this password has been hacked so many times. You should change it. I know mine is hacked, but I never put the effort to change it. I'm like, who's gonna hack me? But it's important that you understand that you as an individual, yeah, they might not hack you. But when they use your data and they bundle it with other services, sorry, when they use your data and bundle it with other people, so I, an individual living in Norway, might not be that important. But we, as a group of people living in Norway, having same kind of age, coming from the same kind of background, this is important for advertisers for these kind of reasons, because they then use this data to offer services. And a very interesting example would be like many companies are not allowed to collect personal data on their companies are allowed to collect personal data, but they're not allowed to use it to sell products. It's a very sensitive thin line over here. But let's say like company ABC had an app. You made an account on their app, and asks you your age, your gender, where your address information, and then it collects data on you on whenever you go to their site and buy a few things. Very basic information. There isn't anything secret about it. The company then in turn collected all this data and it's sold to a third company. And that third company is just a data broker. They buy data from these kind of sites. So what they did was they now have information. So this is a legal thing, okay? They're not selling your name, but they're selling an individual who is a gender, this or that, has a specific age, lives in this postal code, and so on. And then that person, that anonymous person, is buying these kind of things and these kind of shopping patterns. When that data is then sold like multiple times from companies to companies, because companies are interested in getting information on what kind of people are living in this postal code, what kind of behavior do they have, what kind of things do they buy. They take this information, even an anonymous information, and then they use that information to train their association algorithms. And when you go there from that postal code having the same gender and the same age, they already know what kind of stuff you're going to buy, because they think people of that gender and that age group in that postal code will be buying that specific thing. So your data has already contributed to those algorithms. Now, a lot of people who make those kind of laws, they saw this very much in advance. And that's why you have those GDPR laws, you have data privacy laws, which are trying to stop and trying to make sure that your data is kind of not compromised. But it's very hard. Do you play like games on your phones? You probably do, yeah. Okay, good if you don't, but if you do it, that's also fine. There are a lot of companies who make free games. There are a lot of companies who make free games. And one of the ways they make money is obviously by ads inside the apps, right? But whenever you sign up, you either sign up through your Google Play account or your Apple Game Play account. And that gives basic information about a person. Now, this information is golden for those game companies. What they do is they give you free games. They give you like really low quality games. They'll keep on pumping those games because it's very easy to make those games. Change a few things in the code and you have a new game. Those companies publish thousands of games in 1 year and they collect basic information about you. So they don't make money on the ads, they don't make money on the games, they make money by selling your data to data brokers. And that's their business model. That's it. They just want to collect information about you. Yeah, there's another economy of buying stuff inside the app, but they collect information on where you clicked on the game, what kind of behavior you had, and then they sell this information perhaps to other gaming companies and so on. So that information is used in those kind of association algorithms. So it's dangerous, yes, but I think it's also exciting because it's a promise of technology which can predict what you want to do. And I like to believe that that's the exciting part of technology. But anything you give to people which can be used against you, obviously, should be, yeah, it's wrong. Okay. Right. Yeah, as I said earlier, so you may also like feature, which is a very big feature, is based on association algorithms. Inside association algorithms, there's an algorithm called a priori algorithm. Now, the a priori algorithm was based on association, but the like button which came on Facebook, the you may also like, or we think you might be interested on those things, is based on the practical implementation of a priori algorithm. All right. Now we are done with the machine learning part. This is what we have learned so far. We have learned supervised learning, unsupervised machine learning. We touched a bit into reinforcement learning. We did not check ensemble methods, and we did not go into neural nets and deep learning. I think this is something which is mostly for the advanced part of machine learning. We don't have to cover that now, but machine learning is okay. Now, if you want to work with machine learning, you have basic idea on what kind of algorithms to use, unsupervised, supervised. Reinforcement, yeah, but I don't think you will work that much with reinforcement. And yeah, so once we come back from the break, we'll talk about the promises of AI and where we are in that ecosystem. So let's take a 15 minutes break and come back at 9:35. So let's talk about limitations with AI. But before we talk about the limitations with AI, so do we all agree that AI is intelligent or smart? What do you think? Okay, how many of you think AI is stupid? Oh my God. We've been studying for such a long time. Still think it's stupid? Okay.
Still messes up information. And we got like 2 years, like from 2021. So we don't got information from 2022. And then kind of messes up using like ChatGPT.
Yeah.
And math, if you try to solve a math problem using ChatGPT, you're gonna get really detailed.
Yeah. Okay.
And you have the Tesla cars driving on their own crashing. We have like a lot of stuff going, but it's getting there.
Okay. I wasn't prepared for that kind of response. I was like, okay, good points. That's something I'm going to discuss in the limitation for today as well. But let's take a step back and let's talk about the definition of being sentient. And the definition about, so what does sentient means, or sentient of an intelligent being? Not even sentient. Sentient is a very far away thing. Let's talk about someone who is intelligent and smart. And who is intelligent? What thing is intelligent for you? Yeah. No, please go ahead.
Person, or I guess an entity that make rational decisions.
Rational decisions. All right, good. If you see ants like going around and picking food from one place to the other, do you think ants are intelligent?
Sorry, ants?
Ants, the insect ant. A-N-T. Perhaps I'm not saying it right. Do you think ants are intelligent?
Extremely.
Extremely, okay. But they are doing one specific thing only, right? They're looking after their food
But
and
it's-
everything. Yeah.
But it's a collective thing, that everybody has a part and they gotta do everything to make a whole big picture.
Okay. We carry on to that one. If you look at, okay, dog is much more intelligent, so we'll not go into that part. But let's talk about animals which fall in the borderline definition of being stupid or being actually smart. Let's take a very simple example. A bird is looking for his food. You think bird is smart? Why not? Why wouldn't you think bird is smart? Yeah, go ahead.
I don't think the bird's smart because he's only looking for something and finds something, so it doesn't do much to get that thing. He just swerves around, and if he finds something, then it's okay. I'm gonna interact. I'm gonna.
But that's your definition. So no, I'm not debating with you specifically, but I'm saying that's our understanding of looking at a bird. Like we think the bird might not be smart enough because it's only looking for food.
But we have falcons. We have other birds of prey. They're smart. They use their intelligence to find and capture the prey. But if we talk about a pigeon who's just walking city pigeon, I would not take that pigeon as very smart. Because
Okay.
he's just finding food, and
Fine.
he's not even worried about the dangers. Because we're human, we are not their friends.
Okay.
They're getting closer to humans.
Fine.
We're not their natural friends.
Okay.
Enemies in their nature.
You have several birds that are pretty smart that go travel far distances and find back to the same place every year. And you have like crows, they can recognize a person. They can, if you destroy their nest, they recognize you for years and hold you.
Okay.
I mean, they're quite smart.
Okay, great. But then we have agreed that there's certain animals who are smart, certain animals who are stupid. So, I mean, there are certain, even though they are stupid, but they are alive, right? They're performing a specific function. Yeah.
The dua bird is an example, I think, that died out because it was a stupid bird.
Very strange examples coming. I'm not prepared for those, but okay, we'll carry the conversation. Okay, they died out on their own because they weren't smart enough.
You have to survive. That's a big.
Yeah. Okay. So we have divided entities into being smart and not being smart. Okay. Now, if you think about something which is intelligent or not, something we can see in front of us, these are animals, these are other objects, these are the other people, and so on. And we associate a certain life association to them. They're smart, not smart. But what about bacteria or something, viruses, which we cannot see? We don't really know if they're smart or not, but they exist alongside us. Okay, so no question over there, but
It's strange to think maybe things that we decide are smart or not. It's maybe because we don't have enough knowledge to understand the way that they are smart.
That is entirely, you're right, because you don't understand how they work. Like even the definition you and I, this debate you and I are having, you think about you have one aspect of looking at birds, and I might have another aspect, your friend might have another aspect, and so on.
I'm glad to find it more if it's smart enough to continue. Like the ants, they're doing something, so they gotta continue doing the same thing over and over and over again. So they're like making something, but like the bird in the city is not doing something. Okay, we have the crows. Like there's the smartest birds. I think they even find how to use tools to get what they need and what they do.
And I completely agree with that. So the reason why I'm making an analogy over here with birds and insects is because I want to take this focus to the algorithm side. If you have an algorithm and the algorithm does that specific thing, an AI algorithm, and it keeps on doing that specific thing, it's not that intelligent enough to understand the world around it, but it's intelligent enough to understand the history. And it's making a decision based on what it has learned. Would you call it a sentient being? It's doing a specific thing, just like ants were doing a specific thing. They're not doing something else, the collective organism, but okay, it's a one organism, not even calling an organism a thing you made, but it learned from its past experiences, and now it's able to make a prediction which might be true or might be false. But would you consider it sentient? Yeah.
I'd say that sentience is a matter of being able to view yourself in the world, basically being able to get other people's perspective and like in their like view.
Right.
And like yeah, you should tell us about monkeys. They were stuff kind of when people say that they're
No.
but yeah.
Perhaps sentient is a far stretch. Perhaps we cannot say the algorithm is sentient, but can we associate or think that an algorithm can be given the same characteristics as an ant?
It can be given the same characteristics as, for example, mocha, the way they steal your food, the ducky brigade. So they learn different techniques. Depending on how old it is and how many experience they have, it's like the older mocha is perfectly much better at stealing your food than the young one because it has experience, learned a lot.
So can we do that? Can we say that?
It's like just natural selection at this point. You either learn to adapt or you don't.
Yeah.
Yeah.
But
But calling that a measure of intelligence is wrong. It's a measure of survival.
right. Okay. So, all right. Good points. So let's keep intelligence out of that. But if you say like it's not an intelligent being, but it's a being which can make a decision on its own based on whatever thing you provided it, like an ant or like this mocha.
I don't know how to
Yeah, seagull. Yes.
So the word sentience was coined in the 1600s specifically to distinguish it from the ability to think, reasoning, and was used to, or the definition is to be able to experience feelings and sensations.
Feelings and sensations. Okay.
So specifically not reasoning.
But feelings and sensations. Very good. Okay. I didn't know that. Thank you. So we're not calling it sentient, we're not calling it intelligent, but we are looking at it as an entity which is making its own decision based on the information, on the history it has learned.
We are calling it intelligence.
Yeah. So my question is, and then we're looking at other animals or insects around us which are doing similar things. I came up with an example of ant. There might be more. Ant might be more intelligent than that and might not be in that category. So my question is that if you make an algorithm like that, would you turn it off?
Like what?
Kill it? Like just
No. I make an algorithm like that. Like what?
like a simple AI algorithm, which is doing nothing more than predicting the stock price movement.
Yeah.
Would you turn it off, considering like you have made an algorithm which kind of behaves in the way like an ant would behave? And the difference between an ant and the algorithm is that ant is something you can see, an algorithm is just making decisions based on what you provide.
An ant is dead if you kill it.
Yeah, but that's the point, right? How you see
An
it.
AI is not dead if you power it up.
Yeah, but how do you? But this is a physical entity and a logical entity. That's my question. Yeah.
We can hurt an ant, we can cause it pain and watch it change how it behaves according to that pain. But can we hurt an algorithm?
That's what I'm asking.
I'm saying no. If that's what you're asking, I'm saying no, you can't
So
hurt it.
so your definition, I'm so sorry to interrupt you. So your argument is based on the fact that if she cannot cause anyone pain, then it's okay. I'm not debating with you. I'm
For
just
now,
asking.
it's-
Yeah,
you
okay.
have a good counterpoint to that. To
Yeah.
take from
the reason why I'm saying this is because we have to look at AI algorithms in a different way, because we are used to looking at everything around us in physical form, something we can see, but we can't see bacteria, we can't see viruses, and there are many. We live in 3 dimensions. There are 4 dimensions, 5 dimensions, n dimensions. There are many dimensions we can't even see. There are certain aspects or religions or cultures who talk about spirits, who talk about ghosts, who spoke, and there are certain theories that they live in different dimensions. So we're not going to cover that part. But look at the dimension you are living in and look at what we created and the algorithms we are working with. And we can't see algorithms who are working in the back end. But if you make an algorithm which is smart enough and it behaves the way any living entity around you is behaving, then the only difference between that living entity and the algorithm is the form and the feelings part and all that. So my question is, if you take the feeling part away and you take the matter form away, you still have some sort of intelligence in it. Would you consider killing that, knowing that this is something is intelligent, might not be intelligent to you, you're sitting over there, but it might be intelligent to me or your friend or someone else. AI is stupid to many people, but AI is very smart to others. But if it's smart enough, is it something you would consider like, oh, I should treat it as an algorithm and kill it, or I should treat it as a sentient being and let it go?
I mean, no, as long as it's not harmful. No.
Yeah, you did the same thing as him, yeah? Yeah, please.
If I'm the creator, I just because I'm such.
Yeah.
My creation. I don't know.
Yeah, okay. What about plants? You create plants. What about, okay, you don't lay eggs we don't lay eggs to insects, but we can get an egg from an insect or something and make sure it grows up.
So do you think that intelligence and quotation being are directly related like that? If there's somebody who is a vegetable who can no longer think properly, should we just off them?
That's a very good question. I don't know. But these are good questions to ask yourself. Like there's a huge
It was supposed to
movement.
be a hypothetical question.
No, but the previous point I made regarding like a plant, for example, there's another study which says like plants also feel pain when we cut them, or vegetables and all that. Like, but
I don't think the level of intelligence is really a valid measure of whether something is alive.
no. So it's not.
I think a plant, the life of a plant is worth more than the life of an AI.
Yeah.
Because it's not alive.
It's not alive. And that's what I'm trying to investigate. Like, what would we consider as something being alive?
Well, if it's AI that cures diseases.
It doesn't matter.
But we have the root system in the plants that talks to each other and do like everything, and that takes over, it kills it, whatever. So if we go to the plant world, we gotta talk about the roots, because they're smarter than at least me.
Yeah, but there are many people who think like ChatGPT is very smart. Do you think it's not smart? Many people. So
I called it stupid, and it says, yeah.
Okay. Many people think like humans are the supreme intelligence. We are the best of the kind. We were made in like the best way, blah blah blah. And then there are others who think like, no, we are not. There are more entities smarter than us. People say like dolphins are smarter than us. There are many groups of discussion around who is smart and who is not. So no one is going to win that race. But there is another kind of life form which is slowly acquiring intelligence. And that life form does not have a shape. We're trying to give it a shape by putting it into robots. But in an actual way, it will mostly exist in it wouldn't exist in any kind of space. It's more like, okay, it's software. So we need to think about how we address it. And then there's a definition called artificial general intelligence, which is when you create an AI which is magnitude times smarter than humans, then you're putting in smarter. And then when you say like ChatGPT is stupid, okay, we can argue with that one. There are many things it does wrong. But if they claim that they make an AGI and it actually works the way it's supposed to work, it changes the whole thinking of how you look at this being, which is an artificial intelligent being. And that's a smart being. And that's a being, okay, it might not qualify on certain values and how we see as life, but then a new discussion will start about rights, about protection, about how should we deal with it, and so on. There are many people I talk to, and they even consider the AI which we have created now in a very limited form as being a very smart being. And they actually think about those consequences of turning it off or not. But you're right, it's a very future discussion. It's not a discussion. Most of the answers I get is like, yeah, turn it off. Who cares? Oh.
But why should we turn it off? The answer on that, why should we turn it off? Like we're humans, right? We start as a baby, we evolve, our brains get smarter, we use we don't get more information, we don't get smarter. So we keep on growing, and today we're reading English and I'm talking Norwegian. I'm still like doing the artificial thing because my mind is like working all the time. And my IA is not working. I just forgot the question I was going to ask.
That's all right. But that's the same as AI would also evolve. The reason why AI algorithms become smarter is that they're constantly fed data all the time.
But that was the question was, why should we then turn it off?
No, I mean, like, you don't have to. The question is, the similar way, if you, okay, it's a very strange thing to say. The similar way that if you are brain dead in a coma and you wouldn't want that person to die, right? Because the person is just sleeping. Because there are certain ethical values associated with that one. And then you see another algorithm which is smarter, and you're like, I can just turn it off.
Don't I talk to each other and like smarter up the other part? Like
I'm not sure if I understand that part.
Well, I saw some robot cars. They just needed they were following the same path, but some of the cars were just on the corners. And when they bumped into each other, they transferred the information from one car to the other car. So the other car started doing the same thing as the first one.
Okay.
Just small cars, you know, like.
I see a point, but I think that's another kind of focus on the conversation. But
Just wondering, because you said one system is working better than the other one. Why don't the other one upgrade itself?
Yeah, it can, but that's where the AGI will come in. The point I was trying to make is that think about there are two kind of areas you need to think about. You think about practical applications, you need to think about how AI will evolve, but then you also need to think about how your understanding and vision of AI will be when you create those AI systems or you see those AI systems evolving. The pace with which ChatGPT was developed, we are thinking that the artificial general intelligence will be there within the next 10 years. But if you have more companies coming in and going this, it might be there a bit earlier than that. That would be a nice discussion to have then when you have like a general intelligence actually making this way. Okay. Okay, I'm gonna quickly go over this one. We have 15 minutes remaining. Thank you for the very good conversation. I just wanted to get your idea. There's no good or wrong answer to that, Alan. Just wanted to get your opinion on how you look at things. And I agree that even though there's a lot of excitement around AI, we still think like AI is just a software application. And it's not wrong to say that. Yeah, it was just a conversation. But let's talk about the limitations with artificial intelligence. We, like a lot of consultancy companies, have been predicting that AI will add around $16 trillion to the world economy by 2030. A trillion is a huge number. I think the 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 total amount of stocks and the values held by Norwegian and NBIM, Norges Bank Investment Management, is around $1 trillion. And we are talking about, and that's like a huge, huge fund. And we're talking about AI alone will add $16 trillion to the world economy. And Google already has said like AI is more profound, whatever is happening in AI is more profound than fire or electricity. Yeah. Now, this third part is what is happening now. A lot of programmers are using plugins like Copilot, ChatGPT, and other kind of plugins to improve their code or even to write code. And yeah, I mean, people are saying like, okay, there will be autonomous robots and they'll be able to do things inside our house. Yeah. There's been a lot of excitement around self-driving cars, and they've been saying like self-driving cars will be able to drive people around. Yeah, it went down, but now the excitement is back up. They're like, yes, we'll be able to do this. Health, most of the promise on AI lies in health. And they've been claiming, a lot of people have been claiming like, we don't even have to hire radiologists, because what do radiologists do? They look at an x-ray, they look at an image, and they tell what kind of problem the patient has. Now, if you make an AI algorithm which has tons of information and gives that a kind of prediction, you don't have to have the field of radiologists at all, because if you just have a look at an image and tell what the person has a disease or not, AI can do that as well. Yeah. Then we see that the total amount of investment in AI has been increasing over time. There's also lots of money coming in from public money, from private money. Microsoft just announced its most recent quarter, and they were highly positive. They beat earning expectations, and that's because a lot of companies are using AI in their general day-to-day life, especially generative AI. So yeah, so I mean, what I'm trying to say is there's a lot of movement around this area and a lot of excitement that, yeah, a lot of money is going in, a lot of stuff is happening. But then we have a person like you sitting on the back who's like, ChatGPT is stupid. And we also have a situation like this, me saying like, where is my self-driving car? I bought my Tesla in 2019. I was like, oh, it's going to be a self-driving car. We still don't have it. We have to keep our hands on the wheels. So the question is like, there's a huge excitement around AI, but let's look at the reality of AI. Where do we stand? And when we look about the reality of AI, we're talking about the promise of a full autonomous system. We have been able to make small scripts. We have been able to make small, smart systems. They work in a narrow domain, but we have not been able to make something which works in a very global, not a global, but like an autonomous way, covering everything AGI, artificial general intelligence. Self-driving cars, yes, a lot of work has happened, but they're still far away. There's a promise. Yes, they will help us a lot out. They will be able to drive us around, but there are regulatory problems, there are data problems, there are edge use cases, there are many things which we have not been able to figure out yet. So self-driving cars are still being used mostly as a marketing thing. There still are problems which we still need to figure out. California started using self-driving cars, San Francisco specifically. So there are robotaxis going around. That's a promise. That's a ray of hope. But that started now. The whole movement around self-driving cars started like around 2017, 2018. And health, yeah, we were like, oh, health will revolutionize, AI will revolutionize health. We don't even have to hire radiologists anymore. But the reality of the fact is that we still are looking for more radiologists. We're not producing enough radiologists, and those radiologists are, they have a stressful time while going to work because they don't even have to look at x-rays. They now have to train AI algorithms as well as doing their work. So our health system is very much stressed out. We're not finding enough people, and use of AI, yeah, it's a promise, but reality, we're not really using. We're not really even using that. Now, you have Microsoft at one end saying like a lot of companies have started to use AI, but then you have a lot of companies which claim to say they're using AI, but they're not using AI at all. And they're like, what exactly are you doing with AI? And they're like, all right, we're doing something, but it's just a promise. And then they're also actual people who do not understand what AI is. And they still don't understand like how this can be used in a practical way in their organization. I meet a lot of companies who are struggling with identifying the first use case they can use in their company to have some kind of effect. Yeah.
It's marketing scheme, basically.
So I'm going to prove it's not,
Oh.
because I work in the transport company,
Yeah.
Luther, right? And we have been able to work with around 18 different AI projects in the last 3 years, and we have been put into production. So then what I'm trying to say is that, okay, your comment was right, but marketing in a way, like people who have been able to sell it are selling it to get more investment and getting more money from one thing or the other. And there are other people who are actually silently putting into production and growing value, but there's a lot of noise around it. And noise creates problems because then everyone wants to jump into it and create something out of it. So the hype of AI has exceeded the science of AI. And many people still think that AI has not been delivered yet. Now, I work on a daily basis with AI, and I do not agree with it, but a lot of my colleagues in other institutions, they agree with this point of view. My job is not to give you my point of view. My job is to give you a point of view from general people. So I do not agree with this part. Having said that, there are a lot of people who still think that AI is a hype, and you should be aware of that part as well. That a lot of people still think AI is a hype, and you have to decide if it's a hype or not. Yeah. Like if you look at driverless cars, so if we look into the claims which these people are making, the claims are pretty solid. And they say like Tesla started with 2018 and still they don't have a full self-driving cars. You still have to keep your hands on the wheel, blah, blah, blah. You have a lot of edge cases coming up, and the edge cases are mostly like if it's very easy to fool like a self-driving car. I don't know if you saw this example, but in San Francisco, some people are against the self-driving car movement. So the way they are stopping the self-driving cars from going around is by putting like a cone, a traffic cone on a car. For some reason, the car gets confused when it has a cone on the front of a car and it stops working. And they figured it out, and then they started doing it to a lot of cars, and they created a traffic jam. And they have not been able to figure this out, and they don't know why this is happening. That's an example of an edge case, something you cannot predict, something you cannot control, but it happens, and when it happens, everything stops down. Then this is very important. When you work with AI, it's very easy to do the first 90%, first 80%, first 70% prediction score for your AI. The next 5%, 10%, 20, 30, whatever, is extremely hard. So when you work with self-driving cars, when you say like, oh, I've created like a 95% prediction, is very good. From going from 95 to 96% is a huge achievement. 1% is a huge achievement for certain in industries. In health, it's a huge leap if you go from 95 to 96. So that takes time because you need more data, tons of data. You need to try tons of algorithms until you find the right one which work for you. Then data is extremely hard. Data, AI, most of AI is data. If you don't have data coming in, you have a problem. Have you heard about Amazon Go? Yeah, Amazon Go, for those of you who don't know, it's like a supermarket idea by Amazon. So you go into a store and you don't have any people in the store. You just go pick up the stuff and you come out. You don't have to pay. It will automatically detect who you are. It will, you have an Amazon account, you go, and then it will just deduct money from your account based on facial recognition. But the idea was so unique. It never existed before. They wanted to try it out, and the only way they could try it out by creating a virtual environment and creating virtual people going in and testing it out, because you don't have the data for this kind of thing to work. So they had to test it in a virtual environment. And then, yeah, number two is very important. When you create something for health, it's health hospitals do not share data between themselves. And data is very sensitive because patients have control over their data. They don't want their data to be shared between one thing or the other. So when you make a system for one hospital, there are a lot of chances it might not work in the second hospital in the same country. So that's why health is hard to crack, because you have data changes all the time. And then data, a lot of bias can occur. You have a proportion of more white faces than black, but you also have more proportion of black faces than white. Consider algorithms being made in Africa might not work in European population, and the same goes other way around. So if I'm based in Pakistan and I'm making algorithm for Pakistani population, I will use the data set from Pakistan. And if that algorithm is working in Pakistan, I cannot use it in Norway, for example. That could be basis of a bias because you cannot replicate the same thing. You have to retrain the algorithm to the population you're making the algorithm for. Discrimination part. When we worked with billet control, ticket control using AI, this was the first thing people asked us. Were we using, what our algorithm does is it tries to predict where people will be traveling without tickets on specific stops. And the first thing we were asked was, are we using any information about the salary for people living on certain areas? And are we making an algorithm which will always point to poor regions of Norway as compared to the richer regions of Norway? And that's a huge cause of concern, because then you're actually making an algorithm which can target certain group of people. We said no, because we're not using any that kind of information. We only use population, how many people are going through a stop. But this is important. You cannot have bias in your data. You cannot have discrimination already existing in your data. Data markets, we already spoke about, like the same, these are dark web data markets, underground, illegal data markets. These are also legal data markets. You can go to Amazon data market and buy a lot of data about different, not personal information, but like general data information you can buy. Yeah. Okay, this is something we have already discussed. I think this is it. So so we are basically done. So in today's class, we actually studied, we're done with machine learning. We are done with limitations of AI. We touched a bit on the philosophical side of AI. How would you deal with AI if you started looking at it intelligently? The next class, I will give a presentation on practical use cases of AI. So that will be all use cases from Luther, all the 18 projects we have done. I'll give a quick overview of that one. So we will cover that in 1 hour. And then we will start talking about generative AI. So I think we have 3 more lectures and then we are done. All right, thank you so much.